Hey YouTube, this is Umo03. In the previous lesson, we started talking about something called callable instances, and basically that enables us to treat an instance of a class as though it were a function that we could pass inputs into and like get something out of or have something printed to the console when we go ahead and call that instance of the class. We're going to like treat it as though it were a function. So anyway, we can go ahead and review what we were taking a look at in the previous video, right? We were taking a look at this queue class, and this is something that we've seen in previous videos. It wasn't too long ago that we were talking about queues, but now we're going to talk again about the stack and queue class in the context of callable instances to understand another magic method that we have available to us. And if you have any questions about frozen sets, I encourage you to go back to the previous video or the one before that to review. But we have a class called myQueue. Okay, so it's called myQueue on line 192. And then on 194, there's a constructor, and it doesn't accept any parameters, but it's going to create an empty list that will implement the queue. And so every time we push elements onto the queue, they're going to be inserted at the end of the list. And every time we pop elements from the front of the we are going to insert elements to the beginning of the list, and we're going to pop them off from the end of the list, right? When we're thinking about a queue, we're thinking about inserting elements from one end and removing them from the other end, right? We talked about a first in, first out data structure. So anyway, we have some instance methods here. We have isEmpty, right? And that returns true as long as the length of self.items is equal to 0. And then we can push an element onto the queue, and then we can also return that element. So that's something new. This line 211 here is something new, right? But you could go ahead and say self.items.insert of 0, item, and then return item. And that would have the effect of adding the element onto the end of the queue. And then you can also say define pop, and so that would remove an element from the beginning of the queue, which is represented as the end of the list. And that's going to take everything except the last element from the list. And it's just going to reassign the items list that implements the queue to be everything that was in that items list except for the last element, because we're popping it off. But then you could also peek at the front of the queue, or I guess at the end of the list, without removing it. And then in order to do that, you would call peek, which is defined on line 229. And so in the previous video, we were talking about this call magic method. And so basically this allows us to define what happens if we try calling an instance of a class. So basically putting parentheses on an instance of a class, that's what it means to call it. And it basically allows you to treat the instance of a class as though it were a function. And so you would say something like x equals class name, right? And so here you would have parentheses, right? So this is basically making a call to the constructor of the class, right? We said that a constructor is a special method that's used whenever we want to create a new instance of a class. You would say something like x equals class name. So x equals myQueue, for example, but then you could go ahead and call x with parentheses, which can accept parameters if you'd like, and we'll see an example of that. But this function is going to call print q, which prints the elements of the queue. But before it does that, it prints one more thing on the console. So it prints that's cool that you can call an instance of a class as though it were a function. Then finally, it calls the print q instance method. And so there's only two other instance methods in this myQueue class to talk about. So the print q says t equals length of self.items minus 1. While t is greater than or equal to 0, print self.items of t minus equals 1. So like we talked about in the previous video, this has the effect of printing the order of the elements in the order that they were added to the queue, right? And so hopefully that's clear to you. So that's why we sort of have to print the end of the list and then work our way to the beginning, because we want to process the people that were entered into the list first, and then the people who came later on. And then we also have a magic method called len, right? And so this is what allows us to define what the length of an instance is. So what is the length of a queue? And pretty intuitively, that should probably be the length of the list that implements the queue. So it's given by the length of the implementing list. And hopefully you've observed all of these doc strings as we've talked about these different functions. So we said one of the principles of being a good software engineer is to have clear documentation underneath your function headers that describes what the function does, what it accepts, and what it returns, if anything. So hopefully that's clear to you. But we can go ahead and try an example, right? I think we already saw an example in the previous video. So I guess what I'm going to do, I'm going to run try Q down here so we can get a sense of what's going on here. And then we're going to have a slightly more complicated example in this video. So we're going to do try Q. So we're going to say b equals myQueue. And so this makes a calls the constructor of the myQueue class in order to create a new instance, right? And so then we're going to say b.push of 73, b.push of 22.4, b.push of hot dog, b.push of e in elephant, which is a true Boolean as we saw in the previous video, and b.push of length of frozen set of 5, 5 is greater than 1. That would be false because frozen sets can only have unique elements, so the length of that frozen set would be 1, which is not greater than 1. And then you could say print of let's remove the front, and then you could concatenate string of b.pop, right? Because b.pop, well, that would be a 73 because that was the first element that was added onto the queue at line 265. But we said that we cannot concatenate an int with a string. We can only concatenate two strings together, and that's why you have to say string of b.pop, and that's why it says let's remove the front 73, and that's the effect of popping the first element that was added onto the queue and has not been removed yet. And then you could also do the same thing, and again 22.4. Look at the front without removing, and then you could say string of b.peak, and that would show you the hot dog without removing the hot dog, right? And then we could go ahead and call this b, right? So there's no function called b up here, right? There's no def b, there's no defined b. And so you have to look at this call magic method. And so if you create an instance of a class which has a call magic method in it, that enables you to treat the instance of a class as though it were a function. And you just put parentheses afterwards, and then you can pass in arguments if you want, and we'll see an example of that in a minute or two. But with this particular example, I wanted to keep it simple, and there's not going to be any arguments into calling this instance, right? So you're just going to say, let's call B. And then it says that's cool that you can call an instance of a class as though it were a function. And then it just prints hot dog and true and false, because we said that in our call magic method, we're going to go ahead and print that's cool that you can call an instance of a class as though it were a function. And then we also said that we were going to call print q. And so that's why these 4 lines are printed to the console. We're going to see another example of the call magic method and also talk about another magic method in this video, right? We've already learned about length and add and less than, right? A lot of cool magic methods, get item and set item, which allow you to treat an instance of a class as though it were a dictionary that you could get values out of by sticking keys into, for example. So we're going to think of another class. So we're going to go back to the stat class now, and this is going to be a more difficult example. But with this constructor, we're going to have basically, we're going to allow a collection of comma-separated arguments to come into the stack when we create a new stack. So it's going to create a new stack defined by an instance of the stat class. It is implemented with a list, just like we saw previously, but we're going to say only unique elements can be added to the stack at the beginning. So let's think about how we would get something like that to work. We're going to say print awesome new stack. So this means that every time we create a new stack, this will be printed to the console, right? And so we're going to create an empty list, and then we're going to say k equals length of start from bottom minus 1. So it's going to be these comma separated arguments. This is called a positional argument, and we've seen it before, but they're going to be treated as a collection of as a tuple. The collection of elements coming in to this constructor when the constructor is called is going to be treated as a tuple. And so if the length of the tuple is like -1, if the length of the tuple is 0, then k is going to be assigned to -1. And this loop is never going to run, and you're just going to start with an empty list as we saw previously. But if you passed in some arguments into this constructor, you would say k equals length of start from bottom minus 1. While k is greater than or equal to 0, consider equals start from bottom of k. So that would grab like basically the last element, the element which would have the last valid index position, because that would be the length of the tuple minus 1. So you could say consider is the last element that's coming into the constructor. If consider is not in self.items, self.items.append of consider. And so that would go ahead and add those elements onto the stack as long as they were unique coming in. So hopefully that's clear to you. And then they would just sort of fill up those particular index positions, okay? But that's just optional functionality. But the point is that you can get a little bit more creative with your constructors, and you can remember that when you create an instance of a class, you don't have to not pass in anything. You can pass in initial arguments like we saw for the person class when we had name and age instance variables. And then we could also figure out whether or not the stack is empty. So return length of self.items equals 0. And then you could say push of self comma item. So self.items.insert of 0 comma item. and then return item. So this is the same push as in the Q class, right? We're still going to be inserting elements into the beginning of the list here. The difference is that with stacks, we're going to remove elements from index position 0. With Qs, we remove them from the end of the list, right? Like from length of self.items minus 1, for example. But with pop, we're just going to say to remove equals self.items of 0, self.items.remove of to remove, return to remove. So that would remove an element from the top of the stack while returning it. And then you could also peek at the top of the stack without removing it. So you would just say return self.items of 0. And then you could also print the stack. So for element and in self.items, print of element. And then you could also have a string representation of a stack. So what this is going to do is this string representation, remember this defines what it means to print an object, to print an instance of a class. And that's what the str magic method enables you to do. And so we're going to say self.print stack. So we're just going to make a call to the print stack function, which, as you can probably guess, is just going to print the elements in the stack. That's what we just talked about. But then it's going to return empty string of 001. So this is an example of list slicing, but it's with a string. And we said that we can access a string by index position. And so basically this would return an empty string, because you have to think about starting at index position 0 of this string and working your way up, but you have to be basically less than index position 0 in order to collect characters, right? But if you had a 5 here, that would take the first 5 characters. So it'd be like EMPTY, but if you put a 0 here, it's going to be an empty string. But the point is not so much in this particular string that you'd be returning, but rather what is printed on the console when you call the method. So when you call str, when you try printing an instance, you only get an empty string as what's returned, but it makes a call to print stack. So it's going to print the elements in the stack. And then you could also have the length of the stack defined by the length of the list which implements the stack. And then you could also add one stack onto another stack. So this adds each top of some other stack onto the current instance of the stack class, returning the current stack after the elements from the other stack have been added onto it. So it returns the new stack after new elements from other stack have been inserted. So you could say, well, not other stack.is empty, self.push of other stack.pop. So you have to think about taking plates from the top of one stack of plates and moving them onto your stack, onto your main instance stack that you're talking about, right? So that's just one example of how you could add one stack to another stack. And the only thing that you would do is call like A plus B for two stacks A and B. And then you could also have a get item dunder, a get item magic method. So you could say this, defines X of item. So what's returned by X of item? If X is an instance of the my stack class, and item is an item that you're passing in. So if item is equal to top, you could return the top of the stack, return self.peak. If item is equal to bottom, you could return self.items of length of self.items minus 1. That would be the bottom of the stack, the item that was least recently added. And then you could say if item equals length or item equals size, return length of self. So we said that the length of an instance of this class would be the length of the list that implements the stack. And then if item is equal to random key, you could just return the string random value, just to show the workings of a dictionary, right? You stick a key in, you get a value out. And then otherwise, if you say item equals items, you could return self. So you could return the particular instance of the stack class. And then otherwise, you could just say not a valid key and then return none. And then same thing happens with set item, right? So you could also say X of item equals value, and you could sort of treat the instance of a class as though it were a dictionary that you could update the values or assign values to. So you could say if key equals new top, self.push of value, like whatever value you declared, and then return that value. But if key equals replacing top, you could go ahead and pop the current top off of the stack, and then you could push the new value onto the stack. So that would become the new top. You'd be replacing the top of the stack. But otherwise, you could say not a valid key, enter a new top or replacing top. And we see another example of escape sequences as we've talked about in previous videos. And then what about the call? So what if we treat an instance of the stack class as though it were a function that we could call? Well, here again, we're going to have a tuple arg. So we're going to have comma separated arguments coming into the function, and they're going to be parsed as though they were a tuple. So this implementation accepts an arbitrary number of inputs and treats that collection as a tuple. The function allows a user to choose which elements are added onto the top of the current stack. And so you're going to say if length of tuple args equals 0, so if you just try calling this instance without any arguments, then you could say, well, if the length of self equals 0, if the length of the stack at that moment is 0, you could just say print no elements and return false. But otherwise, you could return self.peak, right? So if you don't pass in any arguments when you call the instance of the class, but your stack currently has some elements in it, you could go ahead and elect to return the top of the stack, right? But otherwise, if you do pass arguments when you do call this instance of the class, you could say q equals 0, while q is less than length of tuple args, response equals input of want me to add this to the top of the stack, yes or no, and then string tuple args of q. So it would show you each of the elements that were passed in to the instance, to the callable instance, and just give you an opportunity to provide yes or no, right? This is an example of collecting user input as we saw at the beginning of the curriculum. And so if the response is not in y, n, y, or n, you could say pass, right? And then q would not be updated. And then you would just start the loop over again. So you would just ask the user the exact same question with the exact same element that was passed in until they give you a valid input that's either yes or no, y or n. So if the response is in y, lowercase or capital Y, you could say, okay, adding string of self.push of tuple args of q. So that would add the next element onto the stack, right? It would push it onto the top of the stack. And then you would just have to remember to update the value of q so that you could process the next element that was passed into the callable instance. But otherwise, if the user says no, you could just increment q and just ask them about the next element. And then you could say, tried adding the elements. The call function is pretty cool. And then you could return true. So anyway, I just want to show you real quickly what we have going on here. And I think we're going to have to talk about the contains magic method in the next video. But what we're going to do is take our time with another example here. So we're going to say try stack. And so this is going to be a more complicated example. So it's going to say A equals my stack of 8, 1, 1, 1, 2. And remember when we created the stack constructor, we said that we were going to allow arguments to come into the stack when we first created, but only if they're unique, right? So we're only going to get unique elements being added onto the stack. And so we would only have an 8, a 1, and a 2 as a result, because we're not going to get extra ones as a result of calling if consider is not in self.items. We have to check that Boolean. But anyway, the length of the stack would be 3 after adding those 3 unique elements, right? It's okay to add duplicates with push. It's okay to add duplicates after you've created the stack, just not at the beginning, not when you first call the constructor. And that's just how we've decided to create this class. So if you say length of stack, that would be 3, and then is it empty? Well, that would be false. And then you could say adding 15, and then 15, you push 15. Adding 20, and then you could push 20. So string of a dot push of 20. So it returns 20. So that would return 20, and it would also add it to the top of the stack. And then you could also say removing the top of the stack, and then you could say string of a dot pop, because the pop function removes the top of the stack. And so that would remove the 20 that you just pushed onto it. And then you could treat the instance as though it were a dictionary. So you could say a of new top equals sup. And according to the get item dunder, remember in the get item dunder that we were talking about a few minutes ago, if we say item equals top, then it's going to return self.peak, right? But in the set item dunder, if you say x of new top equals some value, it's going to push that value onto the top of the stack. That's the effect of that magic method, right? And so then anyway, we can go ahead and figure out, so we could say x of new top equals sup, so it would push that onto the stack. And then you could say a of replacing top equals, current a of tops, that would be sup concatenated with not much. That's an example of one of our string formatting techniques. So now the new top of the stack would be sup not much. And then you could call a of 400, 800, 800, 800, and 900. And now it's going to ask us if we want to add each of those elements onto the stack. So 400, yes. 800, yes. 800, yes. 800T, let's give it a weird input. So here it just asks us again, right? So here it's not incrementing that value of Q. So it's just going to ask us over and over again until we give it a valid Y or N. And then it tells us that it's not going to add those last 2 elements, but this is our stack, right? So we're going to have 800, 800, 400, sup not much, 15, 2, 1, and 8. So these are the elements in the stack printed from top to bottom, from most recently removed to from most recently added to least recently added. So hopefully that was clear to you. We're going to talk about one more magic method and a few more Python techniques in the next video, which is actually the last one. From Emails03, thanks for watching, and please subscribe.